This is half past paper week 11 for the higher tier, all the odd numbers today, and these are all the topics that we're going to look at in this paper, the number of marks that they are allocated, and the Sparks code. 42 marks in total today. A whole paper is 80, so it's just about half of a past paper. We'll do all the even numbers next week on week 12. Okay, question number 1, and we have a universal set. So that funny squiggly E, that is called the universal set. And that's everything you know about right now. So your universal set, you can think of it like your universe. Your universe right now is the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. You don't know any other numbers. And your universe, this box, needs to have all of those numbers in it. Okay, so they need to go somewhere in that box. Now we're told that set A is 1, 5, 6, 8, 9. And we're told that set B is 2, 6, 9. So are there any numbers in common? Yes, there are. There's 6 that is in both and 9 which is in both. I then just need to put the 2 from B on the outside, which makes that circle complete for B. And same with A, I've got a 1 left on the outside, a 5 left on the outside, and an 8 left on the outside. Now a lot of students would stop there. But remember, that universe needs to be complete. That squiggly E up there in the top corner means that all of the numbers in my universal set need to go somewhere in this box. So I've got 1, I've got 2, but 3, 4, 5 and 6 are there, and 7 need to go on the outside. Let's just double check we've got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9. So yes, I'm happy. I've got all of the numbers in my universal set somewhere in that rectangle. So we've completed the Venn diagram to represent the information. A number is chosen at random from the universal set. Find the probability that this number is in the set A intersection B. So there's 2 of these that you need to remember. Well, a couple more, but 2 that come up a lot. This is called the intersection, and it's talking about the bit where A and B overlap. So the numbers that are in A and also in B. If you're asked for this one, that's called the union. And the union means they can be in either of them. So we don't mind if it's in this bit or in the middle or in the other bit. So for A and B, A and B. So if you're asked this one, I like to think of it like the grabber machine at the arcade. It's very, very picky at the arcade, and it's only going to pick them up if it's in that middle bit. This one, you can think of it like a bucket. Just going to scoop all of those numbers in. That's how I remember it. I know it's a little bit silly, but it helps me to remember. So there we go. Find the probability of the numbers in the set A intersection B is the question here. We've got 9 numbers altogether. So if you put out of 9, that's going to get you a mark. You'd need a number on the top, but out of 9 is going to get you your first mark. And there are 2 of them in the intersection. We're just looking at this section here. What's the probability of picking a number from that section? It is 2 out of 9. Question number 3, the table shows information about the heights of 80 plants. Find the class interval that contains the median. So the median is the middle value. There are 80 plants here. So with 80, we would add 1 and divide by 2, which is 40.5. What that does when you add 1 to the number of pieces of data and divide by 2, it tells you the position of the middle piece of data. So 40.5 tells me that we are looking between the 40th and the 41st piece of data for the middle piece of data. Now our first 7 plants are in this category. We've not yet got to the middle. I've then got another 13. So up to here, that is 20 plants altogether. I've then got another 14. That takes us up to 34 plants in the first 3 sections. Now I've got another 12, and that's going to take us up to 46. So we now know that both the 40th and the 41st plant were in this category here. So the category that we're going to write down, the class interval is just another way of saying category. Because there are 12 plants in that category, and that included the middle ones, we're going to say that 40 to 50 is our median class interval. So the class interval containing the median. The middle number is in that category. On the grid below, draw a frequency polygon. So a lot of you, if you've watched a lot of my stuff, will hear me talk about Polly the shark. So normally frequency polygons, they kind of make that shape. I always think they look a bit like a shark fin. And we remember that Polly the shark lives in the middle of the ocean. And that's going to hopefully help you to remember to do a graph that looks a little bit like this with straight lines. Don't ever join it up. It'd be a bit mean to chop off Polly's body. and never join it to the origin. She's in the middle of the ocean, so it's going to make like a little floating shark fin in the middle there, and also we go in the middle of the category. Just helps you to remember some little things that in the exam might be helpful. So here we go, we're going to go in the middle of the category. If the category is 10 to 20, we're plotting at 15. So 15 goes up to 7. Be really, really careful. That's 6, that's 7, that's 8, that's 9. A lot of students just go up 2 squares from 5 and think that that's going to get them to 7. It's actually 4 squares higher in this case. So we're going to go to 15 and up to 7, which would be there. Next point is going to be 25, because that's in the middle of that category, going up to 13. So that's going to be 11, 12, 13 there. Next one is 35 and up to 14. No, I'm 1 square out. There you go, like that. 45 going up to 12 is there. And then I've got 55 going up to 16. Not the nicest squares, these, are they? 55 up to 16 and 65 up to 18. Now, I remember the year that my Year 11s came out of this exam because they said to me, Miss, Polly had 2 fins. It kind of goes down and comes back up. Now, I'm not saying it's always going to make a perfect shark fin shape, but it's just to help you remember that it isn't a bar chart, and that we need to join them up with straight lines. So there we go, something like that. I hope it just helps you remember. With a cumulative frequency, you plot at the top of the category, it's a smooth curve. So little tips and tricks to help you remember which graph is which. Never join it to the origin, okay? And never join them up like that to make a polygon. This is a frequency polygon just like this, okay? Question number 5. The diagram shows a hexagon. The hexagon has one line of symmetry. So we can see that there is a line of symmetry like that, which means it's symmetrical, means that both sides are the same. So I know that that angle is 117, for example. These 2 sides are the same, and these 2 sides are the same. Great. Angle BCD. So if you go from B to C to D, the angle you're making is here. So angle BCD is double angle CDE, which is this one here. So therefore I'm going to call this one X and I'm going to call this one 2X. So I also know that this one is 2X and I also know that this one is X. Work out the size of angle AFE, which is this one over here. Okay, so I know that this is a hexagon, and angles in a hexagon add up to 720. Angles in a triangle add up to 180. Angles in a quadrilateral add up to 360. Angles in a pentagon add up to 540. Every time you add another side, you add another 180 degrees. So those ones I just know. Hexagon, 720. If you ever aren't sure, remember there's a formula. It's the number of sides, take away 2, times by 180. So in this case, because it was a 6-sided shape, 6 take away 2 is 4, and 4 times 180 is 720. So I now know that all of these angles, 1, 2, 3, 4, 5, 6, must add together to equal 720. So I've got x, add 2x, add 2x, add another x, which altogether is 6x, because think these ones are 1x and 1x. So 6x, add, and then I've got 117, add another 117, which is 234. And we know that that needs to add up to 720. And I'm just going to solve this equation to work out what x is. So let's start by doing 720 take away 234. And that is 486. So I know that 6 lots of x needs to equal 486. Let's then divide that by 6. And that is 81 degrees. Therefore, this angle here is 81, and this angle here is 81, and the ones that are 2x are double that, so 162 degrees, and that's going to be the answer that they're looking for. We must show all our working, but there was no reasons that we needed to give there, so we're okay with just maths on that one. 162 degrees because we wanted 2x, so 81 times 2, and that was 162. Well done if you got that. Question number 7. work out this. So I'm going to type this in my calculator exactly as it is. There is a fraction and there is a square root. Now, depending on whether the square root is just round the numbers on the top of the fractions, if it was like this, then we would press the fraction button first and then the square root. But because the square root is going round everything, we want to press the square root button first. So I'm going to press square root and then I'm going to press that fraction button. 2.5 times sine 43 is all going on the top. Close that bracket and then use your down arrow on your calculator to go to 8.2 squared minus 50.5. If you don't have a Casio calculator, that's going to be quite tricky. So I would really recommend having one for the exams. That is 0.319141985. So you're writing all of the digits on your calculator display. And then it says give your answer correct to 3 significant figures. So I'm going to write 0.319. And that's for 2 marks. Question number 9. A company has to make a large number of boxes. The company has 6 machines and all the machines work at the same rate. When all the machines are working, they can make all the boxes in 9 days. The table gives the number of machines working each day. Work out the total number of days taken to make all of the boxes. So a company has 6 machines and it takes 9 days to complete all of the boxes that they need to make. So we're going to do 6 times 9 and that is 54. So it needs 54 days of machines running. We know that if all 6 machines are running, then it takes 9 days. So we need 54 days of machines working. So if there was only one machine, it would take 54 days. We need 54 machine days, if that makes sense. So on day 1, we've got 3 machines running. So that is 3 machine days. I've then got 4 running on day 2, 5 running on day 3. All the other days, 6 of them are running. So far on day 1, on day 2 and day 3, we've got 12 days of work done. 12 days of work done so far. So if I do 54 and I take away 12, that's going to get me 42 machine days left. So I need 42 more days of work. Now they don't need to be one day after the other. We've got 6 machines running each day from there on out. So I'm going to do 42 divided by 6 and that is 7 days. So I need 7 more days after these first 3 days in order for it all to get done. So that is going to be 10 days altogether. I've had day 1, 2 and 3 and then I need to add on 7 more days. So therefore in total that's going to take 10 days to get it all done. And that was 3 marks. Question number 11. In May 2019, the distance between Earth and Mars was 3.9 times 10 to the power of 7. In May 2019, a signal was sent from Earth to Mars. Assuming that the signal sent from Earth to Mars travelled at a speed of 3 times 10 to the power of 5 kilometres per second, how long did the signal take to get to Mars? And our answer here needs to be in seconds. So this is a speed, distance, time question, but involving standard form. So I'm going to write that triangle: speed, distance, time. They are asking me how long it took, so they're asking me for the time. To find out the time, we cover that up and we do the sum that's left behind, and that's going to be distance divided by speed. So the distance is 3.9 times 10 to the power of 7, and we're dividing that by the speed, which is 3 times 10 to the power of 5. Always check your units. The distance is in kilometres, the speed is in kilometres per second, and our answer is in seconds. So I'm happy that all those units match up. I'm just going to use my calculator. I'm going to use the fraction button, 3.9 times 10 to the power of 7 on the top, and 3 times 10 to the 5 on the bottom. And that gives me 130. So that's going to be 130 seconds. Nothing to convert there. We were all in the same units, all good. The speed of a signal sent from Earth to Mars in May 2019 was actually less than that. So the speed was actually slower. How will this affect your answer to part A? So there's a couple of ways we can think about this. If the speed is slower, it's going to take longer. If we're going at a slower speed, it's going to take longer to get there. So our answer to part A will be bigger. Our answer to part A will be bigger. A slower speed means it will take longer. Now this question comes up a lot with how if you change the question slightly or if you change your sum, what would happen? Now when you're dividing, if this number, the denominator, goes down, which is what they're saying, we're actually dividing by a smaller number. And when you're dividing by less, if you think about a cake and you're sharing it with less people, you actually get a bigger slice. So that's going to make that answer bigger. If you made the numerator of a top number smaller, then your answer would get smaller. But if you're dividing by a smaller number, it makes your answer bigger. So it would take longer in that case. Question number 13. The density of ethanol is 1.09 grams per centimetres cubed, and the density of propylene is 0.97 grams per centimetres cubed. 60 litres of ethanol are mixed with 128 litres of propylene to make 188 litres of antifreeze. Work out the density of the antifreeze. So again, we're going to use that formula triangle, density, mass, volume. Now, I like to draw little tubs for these. I know a lot of teachers just like to do a table, but I like a picture. So there we go. This is going to be our ethanol, and we're adding that to our propylene. And that added together is going to give us our antifreeze. So let's call that with a little a. And in each of these little tubs, I like to put density, mass and volume, density, mass and volume, and density, mass and volume. So now we're going to fill in what we know. The density of ethanol is 1.09 grams per centimetres cubed. Density of propylene, 0.97. We don't know the density of the antifreeze. That's what we're trying to work out. Now, you cannot add densities. Density is a compound measure, grams per centimetres cubed. Your mass is going to be in grams and your volume is going to be in centimetres cubed. So you can add together grams, you can add together masses, and you can add together volumes, centimetres cubed, but you can't add together a compound measure like this where it's made up of two things. In the same way you can't add speeds, but you can add distances and you can add times. Okay, so now we've got the mass. So we haven't got the mass, we've got the volume. 60 litres of ethanol. So 60 litres. Now, we could convert it into centimetres cubed, but because it's all going to be universal, it's not going to make a difference. So I'm just going to go for 60 litres, and 128 litres of propylene makes 188 litres of antifreeze. You could convert them all, but it's not going to change your answer, so it's absolutely fine just to leave them like that. Now, I want the mass of each of the ethanol, propylene and the antifreeze. To get mass, if we cover that up, it's density times volume. So 1.09 times 60 is 65.4. And then 0.97 times 128 gives me, for the mass of the propylene, 124.16. And then I can add those together to get the total mass. 65.4 is going to be 189.56. Now, if I want the density of the antifreeze, I'm going to do mass divided by volume. So 189.56 divided by 188, and that gives me a final answer. Let's write down what I've done there. 189.56 divided by 188, which equals 1.0082978. We want our answer to two decimal places, so 1, 2, but the 8 rounds up. 1.01 would be our final answer for that one. Question number 15. The graph of the curve C with equation y equals f of x is transformed to give the graph of the curve S with equation f of minus x minus 3. The curve on C with coordinates 7, 2 is mapped to the point Q on S. Find the coordinates of Q. So this is transformations of functions. If I have a graph f of x, if I want to do f of minus x, that is a reflection. It actually takes the graph, whatever it is. Let's just say it's a quadratic, okay? So let's just draw a quadratic C. And we'll draw a quadratic 7, 2. So we'll say that there's a point on this graph, can be whatever you like. We'll just do a lovely graph coming down like that. There we go. So we'll say that that's C, and we'll say that's f of x. Now, if we want f of minus x, that's a reflection. Anything inside the bracket always affects the x-axis. So this is actually reflecting across the y-axis over here. So a reflection like that is going to take our coordinate 7, 2, and instead of it being 7, 2, it's now going to be minus 7, 2. It's going to make that x negative, which makes sense. So we've now got that point there. Putting minus 3 afterwards moves it down 3. So we're going to take that graph and move it 3 lower, which means it's then going to dip into the negative. If it's currently at 2 and we're going 3 down, that coordinate is going to be minus 7, minus 1. It is just a case of learning what those do. Transformations of functions, that's called. If you had minus f of x, for example, it would have reflected the other way across the x-axis. So learn what they do. It's probably grade 8, 9 listed on most revision websites. So yeah, it's a good one to learn. Okay, question number 17. Here are 4 graphs. We've got graph A, graph B, graph C, and graph D. Match each description of the function in the table to the letter of its graph. So before we do this, let's just have a look. This one is a trigonometric graph. It starts at 0 and then goes up and down. That is probably going to be y equals sine x. Okay, sine is an S starting at 0. Obviously, it goes on forever and ever. But cos is a cup, and cos starts at 1. That's how I remember them anyway. There we go. So cos starts up there at 1, whereas sine starts at 0. But that's going to be trigonometric. And then for B, I've probably got either 1 over x, or 2 over x, or 3 over x. This one is called a reciprocal graph. Graph C, it is getting bigger, but not by much. That's actually the graph of root x. And graph D is exponential, something like 2 to the power of x, or 3 to the power of x. So that one's exponential growth, and it would always cross at 1 unless there was another constant to consider. Okay, so inversely proportional to x. Inversely proportional to x, that's just going to be this one. As one gets bigger, the other one gets smaller, so that's going to be graph B. Trigonometrical, there we go. So we've got graph A for that one because it's a sine graph or similar to. F of x is an exponential function, so getting exponentially bigger, that's going to be graph D. And then f of x is directly proportional to root x, that's going to be C. There are lots of those, they appear lots in past papers, just get to know your graphs and what they look like. Question number 19, and it's a bounds question. So we're told that D is u squared divided by 2a. U is 26.2, correct to 3 significant figures, and A is 4.3, correct to 2 significant figures. Now, when they say this, correct to 3 significant figures or what have you, they're saying we've rounded it to that measure. There is a biggest and a smallest, an upper and a lower bound that it could have been beforehand. So if it's been rounded to 26.2, the smallest it could have been was 26.15, and the biggest it could have been is 26.25. I know if it actually equaled 26.25, then it would have rounded up, but with bounds, we just say that that's the upper limit, and therefore we would use that value. For A, similar thing, the upper bound would be 4.35, and the lower bound would be 4.25. Okay, so seeing those values is going to get you some marks. Calculate the upper bound for D. Give your answer correct to 6 significant figures. So we know that D is u squared over 2a. Now, if we want D to be as big as possible, then we want to make this value as big as we possibly can, but we want to divide by as little as possible, because dividing by less is going to make our answer bigger. If you share something with less people, it's going to get you more. So we want to make that one as small as possible. So I'm actually going to do D equals the biggest u I can, so 26.25 squared, divided by 2a, where a is as small as I can possibly make it. So 2 times 4.25, and that's going to get me the upper bound. Popping that in my calculator then, I've got on the numerator 26.25 squared over on the denominator 2 times 4.25. And that is 81.0661764705888 and so on my calculator. And there's actually a recurring here, but I don't know what it goes on to. Probably something keeps going way, way, way beyond that. So 6 significant figures means 81 is my first 2 significant figures. Point, that's the 3rd significant figure, 4th, 5th, and the 6th significant figure would be a 1. And the next number is a 7. The recurring would be like all of this is repeating. So at the end of that recurring, it would go back to that 17647 and then go back to that and then go back to that. So don't worry about the recurring. The 7 would round up and that would become a 2. 1, 2, 3, 4, 5, 6 significant figures would be 81.0662. The lower bound for the value of D is 78.6003. Correct to 6 significant figures. By considering bounds, write down the value of D to a suitable degree of accuracy. So they've told us that the lower bound is 78.6003 and we just worked out that the upper bound is 81.0662. Now when we are writing it to a suitable degree of accuracy, we want to say, well, how many significant figures can I go before they're different? So firstly, let's look at the first digit. If I was to round them both to 1 significant figure, I get 80. This number rounds to 80 and this number rounds to 80. So they both agree. Let's check 2 significant figures. If I round this number to 2 significant figures, I would get 79 because the 6 would round up. This number would round to 81, so then they're different, so I don't want to do that. So I would say, by considering bounds, we're going to round to 1 significant figure, 80, because they both agree to 1 significant figure. It's quite unique. When it says by considering bounds, that's what they mean. Okay, question number 21. The histogram gives information about the distribution of the weights of some onions grown by a farmer. So on a histogram, the area of the bar is the frequency. Up the side here, it says frequency density. That does not mean how many onions. That's just the number that you would multiply this width by to get the frequency. So if I'm looking at this first section, for example, this first bar, it's 60 wide and 2 tall. And if I do 60 times 2, the area of this bar is 120. So I know there are 120 onions that weighed between 0 and 60 grams. And so on. Let's see what the question's asking. Onions less than 60 grams in weight are used for pickling. So that's the ones we just looked at. Onions greater than 120 grams in weight are sold at the market. So that's going to be these 2 bars up here. They're going to market. The rest are sent to a food processing factory. And then a pie chart is drawn using the information opposite to show what the farmer does with the onions he grows. The angle of the sector for onions sent to a food processing factory is X. Work out the value of X. Okay, so we just need the proportions here. So let's get the values. So the area is base times height. These are all rectangles. So for this next bar here, I've got 30, that's my width, times 5, so 150. For the next one, I've got 30 times 9, which is 270. For this bar here, it's going from 120 to, what are we going up in here? 1, 2, 3, 4, 5 squares is 30. So we're going up in 6s per square, yeah, that makes sense. So therefore it's going to be 6, 12, 15. So this is 135, which means the width of that bar is 15. 15 times 6 is 90. And then from 135 up to 180, that is 45. 45 times 2 is another 90. So I've got 180 going to the market in total. That's 90 add 90. I've got these ones, 270 add 150, which is 420, going to the food processing, and I've got 120 that are going to be pickled. So therefore, in total, if I add all of those together, 120, add 420, add 180, there are 720 onions altogether. That's the total number of onions. We're looking at the ones sent to food processing, which is 420. So I know that this section here represents 420 out of 720. And I want to know what fraction of 360 degrees is that. Now you might be able to spot it from that, maybe you can work it out, but I'm going to do it properly just in case the numbers weren't quite as nice. 420 over 720, we want that fraction of 360, and that would indeed be 210. So you can type it in your calculator like that. Makes sense. If it's 420 out of 720 out of 360, it would need to be half that, so 210. 210 is your answer for 4 marks. Just remember, histograms always look really scary, but just remember that the area of the bars is how much frequency is in that category. Base times height, area of a rectangle. Okay, and last but not least, one of my favourite questions this. Question number 23. The diagram shows the positions of 3 towns, Acton, Barston and Chorlton. Barston is 8 kilometres from Acton, so they've given that there for us. Chorlton is 9 kilometres from Barston and on a bearing of 150 degrees. All this information is on the picture for us. Find the bearing of Chorlton from Acton. So I would like the bearing. Now it's going to help to draw this line in. Acton to Chorlton. The bearing of Chorlton, I can't say it, from Acton. So they're asking us, bearings start north and go clockwise. So they're asking us, what is that angle there? So we've got the 37 bit already. It's going to be helpful if we can get this angle here, because then we can just add it on and that will be our answer. So I'm going to pop a little X here because that's what we're trying to work out. Now at the minute, I've got some information and it's feeling like either the sine rule or cosine rule. I've got a triangle, I've got some angles and I've got some sides. Let's fill in what I know. I know this angle. Now, if I was to draw around here, along here and up here, we know that the 2 sides going north are parallel and therefore this is making co-interior angles. So if I know that one angle is 37, I know the other angle needs to add with it to make 180. So that's going to be 143 degrees for B, and that's going to allow me to work out this angle here because we know that angles around a point add up to 360. 143 add 150 is 293. 360 take away that is 67 degrees. So I've got 67 degrees here. So I now need to think, what information do I know? That's pretty much all I can do. I can get this angle, but it's not going to help me too much because it doesn't help me get this or this. I don't know what this breakup of that is. So what have I got? I've got 2 sides and the angle in between. And we know that that's the perfect setup for cosine rule. So let's get this side, I'll call it Y over here. And if I can get that side, then I'll have a pair and we'll be able to do the sine rule. So let's start by doing cosine rule. A squared equals B squared plus C squared minus 2BC cos capital A. This needs to be my little a over here. I know it's not opposite capital A, but we can just rename these. It doesn't really matter as long as this one is your capital A. So there we go. 8 and 9 are your B and C. Let's get that side opposite. So 8 squared, add 9 squared, minus 2 times 8 times 9 times cos 67. That is A squared, and I'm going to just need to square root that answer. So 8 squared, add 9 squared, minus 2 times 8 times 9 times cos 67 gives us an answer of 88.7347175. But I'm going to square root that answer because I don't want A squared, I just want A. So A is 9.419910695. So we'll put that here, 9.419910695. Notice I'm not rounding anything because I want to be super accurate with my answer. Now what I'm going to do is I'm going to do the sine rule, and I'm going to look at these two, this pair here. I've got this side and this angle, and I'm going to use the 9 with the angle that we're interested in. So because I want an angle, angles are going on the top. Sine A over A equals sine B over B. So that is sine 67 over the answer I just got, which is that 9.41, equals sine X over 9. And to get sine x on its own, we're going to times both sides by 9. So in my calculator, I'm typing sine 67 over that answer of 9 point whatever it was, times by 9. So I'm just going to use the answer button on my calculator. I haven't cleared it, and I just want to get all of the decimal places to keep my answer super accurate until the very, very end. So that tells me that sine x is 0.8794715, but remember that when we want an angle, we have to do sine to the minus 1, and that means that x is 61.5786. We're adding that on to 37 because remember the bearing has to start from north. So bearings start north and go clockwise. Add 37 to that. And that gives me 98.578. Now it says give your answer correct to one decimal place. So 98.5786 is my answer. One decimal place is 98.6. However, bearings have to have 3 digits. So we're going to write 098.6 as our final answer. If it's under 100, you're going to need to put that 0 in front. 098.6. So that is bearings and trigonometry. Very tricky as the last question, but hopefully you were able to follow along. This was the cosine rule down here, and this was the sine rule up here. So if either of those weren't clear, that would be something to add to your revision list. If you've got any questions at all, let me know in the comments. I'd be happy to help, and I will see you guys for all of the even numbers of this paper next week on week 12. Thanks, and see you next week.